Hello everyone. Today we're going to do a topic on database management system. The topic is data abstraction, knowledge representation, and ontological concepts. Data abstraction. Data abstraction is a fundamental concept in database management system. It refers to the process of hiding the complex interpretation details of data storage and manipulation while exposing only the essential features of the data. This allows users and applications to interact with the data at a higher level of understanding without needing to be concerned with the intricacies of how the data is stored or retrieved. In essence, data abstraction provides a simplified and standardized view of the data, which enhances usability, reduces complexity, and facilitates data independence. Knowledge representation. In the context of database management system, knowledge representation refers to the process of structuring and organizing data in a manner that captures not only the data itself but also the semantics, relationships, constraints, and rules associated with that data. Here's a more detailed explanation. Structuring data. Knowledge representation involves structuring data in a way that makes it meaningful and interpretable by both human and machines. This often entails defines entities, attributes, and relationships between entities to model the real world domain that the data represents. For example, in university database entities might include students, courses, and instructors with relationships such as enrollment and teaching association. Semantic meaning. Beyond mere data values, knowledge representation captures the semantic meaning of the data. This includes encoding domain-specific knowledge about the relationship between data entities and their attributes. For instance, in a medical database, knowledge representation might capture that a patient has certain diagnosis, which is linked to specific symptoms, treatments, and medication. Rules and constraints. Knowledge representation (DBMS) also involves specifying rules, constraints, and dependencies that govern the data. These rules can enforce data integrity, consistency, and correctness. For example, in a financial database, rules might dictate that a transaction cannot be recorded without a corresponding valid account and sufficient funds. Inference and reasoning. Effective knowledge and representation enables DBMS to perform inference and reasoning tasks. By encoding domain knowledge into the database schema using logical constraints, the system can infer implicit relationships, derive new information, and make decisions based on the available data. This is particularly useful for data analysis, decision support, and automated problem solving tasks. Abstraction and generalization. Knowledge representation allows for abstraction and generalization of data. Instead of representing every detail explicitly, the database schema can capture high-level concept and relationship, which facilitates data understanding and manipulation. This abstraction layer shields user and application from unnecessary complexity while still providing access to the relevant information. Flexibility and accessibility. A well-designed knowledge representation scheme in a database management system should be flexible and extensible to accommodate changes and evolution in the domain over time. This involves designing the database schema in a modular and adaptable manner, allowing for the addition of new entities, attributes, and relationships without requiring significant redesign or disrupt to existing functionality. In summary, knowledge representation in DBMS goes beyond mere data storage and retrieval. It involves structuring data in a way that captures semantic meaning, rules, constraints, and dependencies, enabling inference, reasoning, abstraction, and flexibility in data management and analysis. Ontology concepts. In the context of database management system, ontological concepts refer to the application of ontological principles and methodologies to organize, structure, and represent the semantics of data stored in database. Here's a deeper explanation. Formal representation of knowledge. Ontology in DBMS involves the formal representation of knowledge within a specific domain. This includes defining the concepts, entities, attributes, relationships, and constraints that govern the domain. By employing a standardized ontology, DBMS can ensure consistency and interoperability in data modeling and integration. Semantic relationships. Ontology concept in DBMS capture the semantic relationships among different data elements. These relationships may include hierarchical relationships, subclass relationship, associative relationship, part of a relationship, and other complex interconnection between entities. By representing semantic relationships, DBMS can support more advanced query and reasoning capabilities. Domain modeling. Ontological concepts enable the creation of domain models that abstractly represent the structure and semantic of a particular domain. These domain models serve as a blueprint for organizing and categorizing data within the database. By aligning the database schema with the domain model defined by the ontology, DBMS can facilitate better data management and analysis. Interoperability and integration. Ontology concepts promote interoperability and integration by providing a shared understanding of the domain schematics among with different systems and applications. By employing common ontologies or ontological mapping techniques, DBMS can facilitate seamless data exchange and integration across heterogeneous environments. Inference and reasoning. Ontological concepts support inference and reasoning capabilities within DBMS. By formalizing domain knowledge using ontological concepts such as axioms and rules, DBMS can perform deductive reasoning to derive new knowledge or infer implicit relationships between data elements. This enables more intelligent data processing and decision making. Overall, ontology concepts in DBMS contribute to enhancing data organization, semantics, interoperability, and reasoning capabilities, thereby improving the effectiveness and efficiency of data management and analysis in various domains. Thank you.